As you find yourself enveloped in the gentle embrace of the evening, imagine drifting serenely among the stars, where the vastness of our universe becomes a canvas for contemplation. As we embark on this journey together, let us first turn our gaze to the familiar expanse of our solar neighborhood. The solar system, our cosmic abode, stretches intriguingly across space, dominated by the radiant presence of the sun at its heart. The sun, a giant sphere of incandescent plasma, bathes its planetary companions in light and warmth, knitting them together in a gravitational dance that has continued for billions of years. In orbit around this luminous star are the planets, each a unique world with its own story to tell. Closest to the sun's glow is Mercury, a rocky sphere scarred by ancient craters. Next lies Venus, shrouded in thick clouds that swirl in a toxic embrace. Earth, our home, follows, a blue jewel teeming with life, a testament to the delicate balance of conditions that make it a cradle for life as we know it. Beyond Earth, Mars stands as a reminder of the planet's volcanic past and the mysteries it holds beneath its dusty surface. These inner planets, solid and terrestrial, lead us onward to the asteroid belt, a region of rocky debris, the remnants of early solar system formation. As we continue our cosmic exploration, we encounter the gas giants, those majestic behemoths that reside in the outer reaches of our solar system. Jupiter, the largest of them all, reigns supreme with its swirling storms and the iconic Great Red Spot, a tempest larger than Earth itself. Saturn, adorned with its stunning rings, follows, its icy particles reflecting the sun's light in a dazzling display. Farther still, Uranus and Neptune, often referred to as ice giants, orbit in a realm of cold and mystery, their atmospheres tinged with blue. These distant worlds, with their gaseous compositions and thick atmospheres, invite us to ponder the possibilities of life in forms unfamiliar to us. In contemplating the potential for life on these immense planets, we must first understand their nature. Gas giants are composed primarily of hydrogen and helium, their atmospheres dense and immense, with pressures and temperatures that increase dramatically as one delves deeper into their gaseous shrouds. Their solid cores, if they exist, lie hidden beneath these thick blankets, shielded from direct observation. In such environments, the conditions for life as we understand it on Earth seem, at first glance, inhospitable. Yet, the universe often surprises us with its capacity for the unexpected. Turning our thoughts to the concept of life itself, it becomes clear that life is, in essence, a process, a complex, dynamic interplay of chemistry and physics. On Earth, life thrives in an astonishing array of forms, from the simplest single-celled organisms to the most complex creatures. It finds a way in environments as diverse as the scorching desert sands and the frigid depths of the ocean. This resilience of life on our home planet encourages us to extend our imaginations when considering where else it might exist. In the context of gas giants, one might wonder if life could adapt to the extreme conditions found within their atmospheres. While solid surfaces are absent, the upper layers of these atmospheres present regions where, theoretically, temperatures and pressures might align more closely with those found on Earth. Could life in some form exist as floating entities, adrift in the clouds, sustained by the chemical reactions occurring in these gaseous worlds? Such a notion requires us to expand our definition of habitability beyond the traditional confines of rocky planets and liquid water. The possibility of life on gas giants also brings to mind the potential role of their moons, which orbit these colossal planets like cosmic satellites. Many of these moons, particularly those of Jupiter and Saturn, have captivated scientists with their unique characteristics. Europa, one of Jupiter's moons, is enshrouded in ice, beneath which lies a vast, subsurface ocean. This hidden sea, kept warm by tidal forces, may harbor the essential ingredients for life. Similarly, Saturn's moon Enceladus, with its geysers spewing water vapor and organic molecules, presents another tantalizing possibility. These moons serve as reminders that the search for life in our solar system is not limited to planets alone. They highlight the diversity of environments that might support life, encouraging us to consider not just where life could exist, but also how it might endure in places vastly different from our own world. As we linger in this realm of gentle curiosity, it is important to remember that the search for extraterrestrial life is as much about understanding the potential for life to thrive as it is about finding life itself. It is a journey that invites us to look beyond our own experiences and to embrace the wonders of the universe with an open mind. It is a pursuit that, while rooted in scientific inquiry, is also deeply philosophical, prompting us to ask fundamental questions about our place in the cosmos. As we ponder the mysteries of life on gas giants, imagine yourself floating gently among the clouds of Jupiter or Saturn, witnessing the interplay of light and shadow across their vast atmospheres. Picture the delicate dance of particles in the rings of Saturn, each one a tiny ambassador from the distant reaches of space. Consider the moons, silent sentinels that have watched over these planets for eons, their surfaces marked by the passage of time and the ceaseless forces of nature. In this moment of quiet reflection, let us acknowledge the profound beauty and complexity of the universe, a tapestry woven with the threads of time and space. Let us appreciate the intricate dance of celestial bodies that define our solar system, each one contributing to the cosmic symphony in its own unique way. And as we continue our exploration, let us carry with us the spirit of wonder and gentle curiosity, ever open to the possibilities that await us beyond the familiar horizon. In the vastness of space, the potential for life, in whatever form it may take, remains one of the greatest mysteries still to be unraveled. As we gently pause in our journey, consider the endless questions that guide us and look forward to the discoveries yet to come. Let us remain ever curious, ever hopeful, and ever respectful of the universe's infinite wonders. As we ponder the vast tapestry of our universe, we find ourselves drawn to the enigmatic allure of the gas giants. These colossal planets, with their swirling atmospheres and hidden depths, offer a landscape both alien and fascinating. It is within these immense, cloud-laden worlds that the imagination is free to wander, contemplating the myriad possibilities of life that might defy our earthly expectations. While the surface of these giants is inhospitable, the potential for life might lie not in the harshness of their gaseous layers, but in the more temperate regions of their upper atmospheres. Here, the interplay between gases creates a dynamic environment where the chemistry of life could potentially find a foothold. The idea of life existing in the skis of these giants is not entirely beyond the realm of possibility. In the upper atmosphere, where pressures and temperatures might be more akin to those found on Earth, the conditions could allow for the existence of microbial life forms. These hypothetical organisms would need to adapt to survive the high levels of radiation and the scarcity of nutrients. But nature has shown us time and again that life can thrive in the most extreme conditions. On Earth, we find life in environments previously thought to be barren, deep ocean vents, acidic lakes, and even in the upper reaches of our own atmosphere. These extremophiles, as they are known, have evolved unique strategies to harness energy and sustain themselves, offering tantalizing parallels to what might be possible on gas giants. Beyond the speculative delight of atmospheric life, we turn our gaze to the moons that orbit these massive planets. These celestial companions, with their diverse terrains and hidden oceans, are ripe with potential for harboring life. Each moon tells its own story, shaped by billions of years of geological and chemical processes. Among these, Europa and Enceladus captivate with their icy surfaces concealing vast oceans beneath. These moons are kept warm by the gravitational tug of their parent planets, which generate tidal heating, a process that could provide the energy necessary for life to flourish. Europa, with its smooth, cracked, icy crust, suggests a subterranean ocean teeming with possibilities. Observations have hinted at the presence of plumes of water vapor escaping through cracks in the ice, offering a glimpse into the ocean below. This ocean, likely in contact with a rocky seabed, could allow for the complex chemistry that life requires. As we dream of what might dwell in these dark, cold waters, we imagine organisms that could exploit the chemical gradients created by hydrothermal vents, similar to the life forms that thrive in our own ocean depths. Enceladus, smaller yet no less intriguing, shares a similar story. Its geysers, spewing water and organic molecules into space, suggest an active subsurface ocean with the potential for life. The plumes of Enceladus are rich with the building blocks of life, hinting at the complexity of the processes occurring within. This constant interchange between ocean and ice shell could create an environment rich in nutrients, possibly supporting a biosphere that, though hidden, is vibrant and complex. As we drift further into the realm of possibilities, we encounter Titan, Saturn's largest moon. Titan presents a unique landscape, with its thick, nitrogen-rich atmosphere and hydrocarbon lakes. This moon offers a stark contrast to the icy worlds of Europa and Enceladus. Its surface is dotted with lakes and rivers of liquid methane and ethane, creating an environment that challenges our understanding of habitability. While life as we know it relies on water as a solvent, Titan invites us to consider alternative biochemistries, where life might flourish under conditions entirely alien to us. In the cold, hazy atmosphere of Titan, complex organic molecules are continually formed, providing a rich chemical soup. These molecules, precipitating onto the surface, could offer the raw materials for life to arise, albeit in a form we might struggle to recognize. Here, the question of life is not merely about the existence of organisms, but about the broader definition of life itself. Could life on Titan be based on methane, using it as a solvent in place of water? Such a possibility stretches the limits of our imagination and expands the scope of our search for life beyond Earth. As we contemplate these distant worlds, we are reminded of the intricate dance of forces that shape them. The gravitational interactions between gas giants and their moons create environments in constant flux. These dynamic systems, with their complex interplay of tides, magnetism, and chemistry, offer a fertile ground for the emergence of life in forms we have yet to envision. Each moon and planet presents its own set of conditions and challenges, each a unique laboratory for the study of life's potential. The pursuit of understanding these enigmatic worlds is not merely an exercise in curiosity. It is an endeavor that touches upon some of the most profound questions of existence. Are we alone in the universe, Or is life a common thread woven throughout the cosmos? To seek answers, we must look beyond the confines of our own planet, embracing the diversity of environments that the universe offers. The gas giants and their moons provide a canvas upon which the story of life might be painted in unexpected hues. In our quest to uncover the mysteries of life beyond Earth, we are guided by the tools of science and the power of imagination. Robotic explorers, designed to withstand the harsh conditions of space, become our eyes and ears on these distant worlds. Through them, we gather data, analyze samples, and expand our understanding of the possibilities that lie beyond. Each mission, each discovery, brings us one step closer to answering the age-old question of whether we are alone. The journey is one of patience and perseverance, requiring us to look beyond the immediate and embrace the long view. As we send probes to the farthest reaches of our solar system, we are reminded of the interconnectedness of all things. The study of gas giants and their moons does not occur in isolation, but as part of a greater tapestry of exploration, where each piece contributes to a more complete understanding of our place in the universe. In this grand exploration, cooperation across nations and disciplines becomes essential. Scientists, engineers, and visionaries from around the world come together, united by a shared goal of unveiling the secrets of the cosmos. This collaborative spirit mirrors the vast interconnectedness of the universe itself, where each celestial body, each atom, plays a role in the grand cosmic dance. As we reflect on the possibilities of life in the outer solar system, we are also reminded of the fragility and uniqueness of our own planet. Earth, with its vibrant ecosystems and diverse life forms, is a testament to the rarity and preciousness of life. In our search for life elsewhere, we are compelled to cherish and protect the life that thrives here, nurturing the delicate balance that sustains us. And so, as we pause in our cosmic journey, we hold fast to the spirit of exploration and discovery. We remain open to the wonders that await us, ever mindful of the profound beauty and complexity of the universe. With each new question, we deepen our understanding, and with each new discovery, we draw closer to unraveling the mysteries that lie at the heart of existence. Let us continue to gaze at the stars with wonder and humility, knowing that the answers we seek may be just beyond the horizon, waiting to be discovered. And so, as we ponder the possibilities of life in the vast expanses beyond our home planet, our attention turns to the intricate dance of elements and energy that define the gas giants and their surrounding realms. These colossal planets, each enveloped in swirling clouds and tempestuous atmospheres, present environments that are both daunting and fascinating. Within the depths of Jupiter, Saturn, Uranus, and Neptune lie layers of gas that, under immense pressure, transition into exotic states of matter. Hydrogen, so abundant here, may transform into metallic liquids under the gravitational forces at play, creating magnetic fields that extend far into space, influencing the charged particles and even the weather patterns of these distant worlds. Jupiter, with its iconic Great Red Spot, a storm that has raged for centuries, serves as a reminder of the dynamic and ever-changing nature of these gas giants. The atmosphere, composed primarily of hydrogen and helium, is a tapestry of bands and zones, each with its own distinct characteristics. Ammonia clouds form majestic towers, reaching heights that dwarf the tallest mountains on Earth, while below, the pressure mounts to levels where the gas becomes a dense fluid. In such an environment, any potential life forms would need to adapt to conditions that are constantly in flux, where energy from the sun, barely penetrates the upper layers, and internal heat sources provide the only warmth in this cold, distant region of our solar system. Saturn, adorned with its magnificent rings, offers another perspective on the potential for life. The rings themselves, composed of countless particles of ice and rock, orbit the planet in a delicate balance, reflecting sunlight and casting shadows upon the cloud tops below. The outer atmosphere is dominated by powerful winds, some reaching speeds far exceeding any earthly storm. Yet beneath this turbulent exterior, there is a deep mystery. Layers of cloud, made of ammonia and methane, obscure our view of the planet's interior, where pressures and temperatures rise to unimaginable levels. Here, as with Jupiter, the possibility of life seems remote, yet not entirely beyond the realm of imagination. Life, if it exists, would need to be resilient, capable of surviving in an environment where chemical reactions occur in ways unfamiliar to us, potentially driven by the heat and energy from deep within the planet itself. Uranus and Neptune, the ice giants, present yet another fascinating chapter in the story of our solar system. Their atmospheres are rich with water, ammonia, and methane, giving these planets their characteristic blue hues. The presence of methane, in particular, absorbs red light, scattering the blues and greens, creating a serene yet alien beauty. These distant worlds, lying far from the warmth of the sun, are shrouded in cold and mystery. Uranus, with its unusual axial tilt, rotates on its side, creating extreme seasonal variations. Neptune, with its dynamic weather systems, hosts the fastest winds observed in our solar system, howling across the planet's surface at incredible speeds. In these frigid environments, life as we know it might struggle to gain a foothold, yet the possibility of alternative biochemistries, perhaps utilizing ammonia or methane in ways we have yet to understand, remains an open question. As we consider these possibilities, our thoughts naturally turn to the role of robotic explorers, our eyes and ears in these distant worlds. These machines, crafted with precision and care, journey across the vast expanses of space, braving radiation belts, gravitational forces, and the relentless cold of the void, to bring us glimpses of the unknown. From the Voyager probes, which continue to send back data long after their primary missions have concluded, to the more recent Juno and Cassini spacecraft, each mission builds upon the knowledge gathered by its predecessors, piecing together a mosaic of understanding that spans decades. These robotic emissaries, programmed to operate autonomously, navigate the intricate gravitational fields of the gas giants, sending back images and readings that allow us to peer beneath the clouds, to study the magnetic fields and analyze the chemical compositions that define these worlds. With each new mission, we refine our models, hone our theories, and expand the boundaries of what we know, always with an eye towards the next horizon. Yet, as we explore these gas giants, we are reminded of the interconnectedness of all things. The gravitational pull of these massive planets shapes the orbits of their moons, influences the paths of comets and asteroids, and even affects the movement of space debris within the solar system. Their magnetic fields, vast and powerful, interact with the solar wind, creating auroras that dance across the poles, visible to our telescopes as distant flickers of light. It is a reminder that even in the vastness of space, nothing exists in isolation. Each world, each moon, plays a part in the grand cosmic ballet, a dance of forces and energies that has been ongoing for billions of years. In contemplating the potential for life on these gas giants, we also reflect on the broader implications for our understanding of life's origins and its potential distribution in the universe. If life can adapt to the extreme conditions of gas giants, it suggests a remarkable resilience and versatility, hinting at the possibility of life in environments we have yet to consider. It challenges our assumptions and broadens our perspective, inviting us to question what it means to be alive, to be sentient, and to be part of this vast, interconnected cosmos. As we continue this exploration, we must also consider the ethical dimensions of our quest. The search for life on other worlds is not just a scientific endeavor, but a philosophical and moral one as well. It compels us to ask what responsibilities we bear as explorers, as observers of these alien realms. How do we balance the pursuit of knowledge with the preservation of the natural state of these worlds? What measures must we take to ensure that our presence does not disrupt or contaminate these environments? These questions, though complex, are essential to the integrity of our exploration, guiding us as we seek to understand our place in the universe. Ultimately, the search for life on gas giants and their moons is a journey of discovery and reflection. It is an opportunity to expand our horizons, to challenge our preconceptions, and to embrace the unknown with open hearts and minds. As we gaze into the night sky, we do so with a sense of wonder and humility, aware of the vastness that surrounds us and the mysteries that await our discovery. Each step forward in our exploration brings us closer to understanding the nature of life itself, not just on Earth, but throughout the cosmos. And so, with patience and curiosity, we continue our quest, guided by the light of knowledge and the spirit of discovery that defines our journey among the stars. In this endeavor, we are united by a shared curiosity, a desire to understand the universe and our place within it. This pursuit transcends borders and cultures, inviting collaboration and cooperation on a global scale. Scientists, engineers, and thinkers from around the world come together, pooling their knowledge and resources in a collective effort to probe the mysteries of the cosmos. This spirit of unity and collaboration is not just essential to our exploration, but also serves as a testament to what humanity can achieve when we work together towards common goals. As we look to the future, we envision new missions that will delve deeper into the atmospheres of these gas giants, that will explore the icy crusts of their moons, and that will search for signs of life in the most unexpected places. We imagine landers that will touch down on the surfaces of distant moons, deploying instruments to analyze the chemical makeup of their environments, and orbiters that will map the magnetic fields and gravitational anomalies of these massive planets. Through these efforts, we hope to uncover new insights into the processes that govern the formation and evolution of planetary systems, and to enhance our understanding of the conditions that could give rise to life. In this grand endeavor, we are reminded that the pursuit of knowledge is an ongoing journey, one that requires patience, perseverance, and a willingness to embrace the unknown. Each discovery, no matter how small, adds to the tapestry of understanding that we weave, enriching our appreciation of the complexity and beauty of the universe. As we continue to explore the gas giants and their moons, we do so with a sense of wonder, ever mindful of the infinite possibilities that await us in the vastness of space. And so, as we conclude this part of our exploration, we find ourselves at a threshold, poised to uncover new realms of knowledge and insight. With each new mission, each new discovery, we take another step forward in our quest to understand the universe and our place within it. Let us continue to gaze at the stars with wonder, knowing that the answers we seek may be just beyond the horizon, waiting to be discovered. As we ponder the vastness of space, our gaze naturally shifts from the gas giants themselves to the numerous moons that accompany these majestic planets. In the delicate dance of gravitational forces, these moons orbit their parent planets, each one a world unto itself, with unique characteristics and potential for hosting life. Titan, Saturn's largest moon, captures the imagination with its thick atmosphere and surface lakes of liquid methane and ethane, presenting a tantalizing opportunity to explore an environment with conditions vastly different from Earth's. In these alien seas, some scientists speculate that life could exist in a form unfamiliar to us, adapted to thrive in the cryogenic temperatures and hydrocarbon-rich atmosphere. Here, the idea of life challenges our Earth-centric view, inviting us to consider the myriad ways life could manifest under completely different chemical and physical conditions. Europa, one of Jupiter's many moons, also beckons with its icy shell and the promise of a subsurface ocean. The gravitational tug-of-war with Jupiter generates tidal forces that warm its interior, creating the possibility of an ocean kept liquid beneath a thick crust of ice. This hidden realm may harbor hydrothermal vents similar to those found on Earth's ocean floors, where life thrives in the absence of sunlight, relying instead on the chemical energy provided by the planet's geothermal activity. Could similar ecosystems exist beneath Europa's ice, teeming with life forms that have evolved in isolation for eons? The prospect is both thrilling and humbling, reminding us that life, in its infinite adaptability, may find a way even in the most unlikely places. Turning our attention further outward, we encounter the ice giant Neptune and its largest moon, Triton. Triton's retrograde orbit suggests it may be a captured object, possibly a former member of the Kuiper belt, now locked in a gravitational embrace with Neptune. This moon is a place of stark contrasts, with geysers erupting nitrogen gas into its thin atmosphere, hinting at dynamic processes occurring beneath its frozen crust. The mysteries of Triton invite speculation about what secrets might lie beneath its surface. Perhaps a subsurface ocean or geothermal activity that could support life in unexpected forms. The exploration of these moons is not just a scientific endeavor, but also a philosophical journey, prompting us to reflect on the nature of life and our place in the universe. As we peer into the cosmos, we are reminded of the interconnectedness of all things, how the fate of a moon is linked to its planet, and how planets influence the evolution of their moons. This cosmic web of relationships challenges us to think beyond our own world, to imagine the myriad possibilities that the universe holds. In the pursuit of knowledge, we must also consider the ethical implications of our exploration. The potential discovery of life elsewhere in the solar system raises profound questions about how we interact with these alien environments. It is imperative that we approach our exploration with respect and caution, mindful of the potential impact our presence might have. The principle of planetary protection guides our actions, ensuring that we do not inadvertently harm these pristine environments or contaminate them with earthly life. As stewards of our own planet and explorers of others, we have a responsibility to preserve the integrity of these worlds for future generations and for the life that may exist there. With each mission, we push the boundaries of our understanding, sending robotic emissaries to gather data and relay their findings back to us. The information they provide is invaluable, offering glimpses into worlds that are both familiar and alien. Instruments aboard these spacecraft measure atmospheric composition, surface temperatures, magnetic fields, and radiation levels, painting a picture of each celestial body's environment. These data are crucial for planning future missions, including those that may one day carry humans to these distant worlds. The dream of human exploration of the outer solar system remains a distant but tantalizing goal. The challenges are immense, from the vast distances involved to the harsh conditions that would greet any visitors. Yet, the human spirit is defined by its curiosity and desire to explore the unknown. As we develop new technologies and deepen our understanding of these distant worlds, the possibility of sending humans on such journeys becomes ever more real. These missions would not only be a testament to human ingenuity, but also a continuation of our age-old quest to explore and understand the cosmos. In contemplating the potential for life beyond Earth, we are reminded of the fragility and preciousness of life on our own planet. The Earth, with its rich biodiversity and complex ecosystems, is a rare gem in the vastness of space. The search for life elsewhere underscores the importance of protecting our own biosphere, ensuring that future generations inherit a planet teeming with life and possibility. As we look outward, let us also look inward, cherishing the delicate balance that sustains life on Earth. The journey to understand our place in the universe is one that requires patience and perseverance. Each discovery builds upon the last, slowly piecing together the puzzle of our solar system and its potential for hosting life. As we continue to explore, we must remain open to the unexpected, ready to revise our theories and expand our understanding in light of new evidence. The universe is vast and full of surprises, and it is only through continued exploration and inquiry that we will come to know its secrets. In the vastness of space, we find not only questions but also a sense of connection to something greater than ourselves. The stars and planets are not just distant objects to be studied. They are part of a grand tapestry, a cosmic story in which we play a part. As we look to the heavens, we are reminded of the shared human experience, the collective curiosity that drives us to explore and learn. It is this spirit of inquiry that unites us, transcending borders and differences, as we seek to understand the universe and our place within it. And so, as we continue our exploration, let us carry with us a sense of wonder and humility. Let us approach the cosmos with open minds and open hearts, ready to embrace the mysteries that await us. In seeking to understand the universe, we are also seeking to understand ourselves, to find meaning in the vastness of space and time. Each step we take, each discovery we make, brings us closer to answering the age-old questions of who we are and where we come from. The exploration of the gas giants and their moons is but one part of a larger journey, a journey that will take us to the farthest reaches of our solar system and beyond. As we stand on the threshold of discovery, let us do so with a sense of purpose and responsibility, aware of the impact of our actions and the potential for what we might find. The universe is a vast and wondrous place, full of possibilities and potential, waiting for us to explore and understand. With each passing day, we inch closer to uncovering the secrets of the cosmos, guided by curiosity and a desire to know. In this journey, we are not alone. We stand on the shoulders of those who have come before us, and we will pave the way for those who will follow. Together, we will continue to explore the universe, seeking answers to the questions that have captivated humanity for millennia. And as we do so, let us remember to look up at the stars with wonder, knowing that the journey is as important as the destination, and that the universe holds endless possibilities for discovery and understanding. As we consider the vastness of the cosmos and the potential for life beyond our home planet, our thoughts naturally turn to the immense gas giants that dominate the outer reaches of our solar system. These colossal planets, Jupiter, Saturn, Uranus, and Neptune, each present a unique tableau of swirling clouds, complex atmospheric phenomena, and an enigmatic array of moons, each with its own story to tell. Unlike the terrestrial planets, these gas giants are composed largely of hydrogen and helium, with no solid surface on which life as we know it could readily take hold. Yet, their sheer size and gravitational influence create an environment where myriad moons dance around them, some of which offer tantalizing hints at the possibility of life. The gas giants themselves are inhospitable to life as we know it, with their thick, turbulent atmospheres, extreme pressures, and frigid temperatures. However, their moons present a different picture, inviting us to imagine the diverse environments that might exist within their embrace. Jupiter, the largest of these gas giants, is orbited by a fascinating collection of moons, each with its own character and potential for harboring life. Among them, Europa stands out as a beacon of hope for astrobiologists. Beneath its icy crust lies a vast, subsurface ocean, kept liquid by the gravitational interactions with Jupiter and its other moons, creating tidal forces that generate heat. Such an ocean could be teeming with microbial life, particularly around hydrothermal vents where water, warmed by geothermal energy, might foster ecosystems similar to those found in Earth's deep oceans. The presence of water, energy, and the right chemical ingredients makes Europa one of the most promising places to search for life beyond Earth. If life does exist there, it might offer profound insights into life's adaptability and resilience in the face of extreme conditions, expanding our understanding of the limits within which life can thrive. Saturn, the second largest gas giant, is not to be overshadowed in this cosmic dance. It, too, hosts a collection of moons that intrigue scientists. Titan, Saturn's largest moon, presents an environment rich in organic molecules, with vast lakes and seas of liquid methane and ethane. This unusual chemistry prompts us to consider the possibility of life forms that might thrive in conditions vastly different from those on Earth. Perhaps there are organisms that have adapted to utilize methane as a solvent, rather than water, reshaping our assumptions about the essential ingredients for life. Then there is Enceladus, another of Saturn's moons, which has captured attention due to its geysers of water vapor and ice particles that erupt from its south pole. These plumes suggest the presence of a subsurface ocean, similar to Europa's, with the added possibility of organic compounds. The Cassini mission, which studied Saturn and its moons, provided evidence of these organic materials, hinting at the complex chemical processes occurring beneath Enceladus's icy shell. This discovery fuels our imagination as we ponder the types of life that might exist in such an environment, shielded from the harsh realities of space by an ice-covered ocean. Uranus and Neptune, while more distant and less explored, add to the allure of the outer solar system. These ice giants, with their own sets of moons and rings, remain largely enigmatic. The faint light that reaches them from the sun creates a world of deep cold and shadow, yet even here, the potential for discovery beckons. The moons of these distant planets, such as Triton orbiting Neptune, challenge our understanding of geological activity and the potential for life. Triton's retrograde orbit and geysers suggest a dynamic world, possibly harboring subsurface warmth and the conditions necessary for life to eke out an existence. As we contemplate these distant realms, the question of how to explore them becomes paramount. The technological challenges are immense, requiring innovations in spacecraft design, propulsion, and life support systems. Yet humanity's spirit of exploration is indomitable, driving us to develop the means to reach these far-flung destinations. The same curiosity that led ancient astronomers to map the stars now propels us to send robotic emissaries to probe the mysteries of these distant worlds. The ethical considerations of such exploration cannot be overlooked. As we venture into these new frontiers, we must be mindful of the delicate balance of these environments. Planetary protection protocols are essential, ensuring that our search for life does not inadvertently compromise the very ecosystems we seek to understand. The introduction of Earth microbes to these pristine worlds could have unforeseen consequences, potentially destroying the evidence of life or altering the natural state of these environments. As stewards of space exploration, it is our responsibility to tread lightly, preserving the integrity of these extraterrestrial ecosystems for future generations to study and appreciate. In the pursuit of knowledge, we are reminded of our place within the vast expanse of the universe. The prospect of finding life on the moons of the gas giants challenges us to redefine our understanding of what it means to be alive. It compels us to consider the diverse forms that life might take, shaped by environments so different from our own. This journey of discovery not only expands our scientific horizons, but also enriches our philosophical and cultural perspectives, inviting us to ponder the nature of life, intelligence, and consciousness. As we look to the future, the dream of sending humans to explore these distant worlds remains a distant goal. Yet, the seeds of this vision are already being sown through international collaboration and the development of new technologies. The exploration of the gas giants and their moons is not merely a scientific endeavor. It is a testament to the enduring human spirit, the desire to reach beyond the known, to seek out new experiences and understandings. In doing so, we reaffirm our connection to the cosmos, recognizing that we are but a small part of a much larger tapestry, woven with the threads of stars and planets, life and possibility. The exploration of the gas giants and their moons also serves as a reminder of the interconnectedness of all things. Just as these massive planets influence the orbits and environments of their moons, so too does our exploration of the cosmos influence our understanding of Earth and our place within the universe. The quest to discover life beyond our planet prompts us to cherish the life we have here, to nurture and protect it, ensuring that future generations can continue this journey of discovery. As you reflect on these possibilities, consider the myriad ways in which life might adapt and thrive in environments far removed from our own. Imagine the alien ecosystems that could exist beneath icy crusts, in methane-rich lakes, or perhaps even in the dense atmospheres of the gas giants themselves. Each possibility invites us to expand our understanding of life's potential, to embrace the unknown with open minds and hearts. In contemplating the cosmos, we are reminded of the beauty and fragility of life, both on Earth and potentially elsewhere. The search for life on the gas giants and their moons is a journey that transcends scientific inquiry, touching upon the very essence of what it means to be human. It is a journey that unites us in our shared quest for knowledge, understanding, and connection to the universe. As we continue to explore the mysteries of the cosmos, let us do so with a sense of wonder and humility, ever mindful of the infinite possibilities that await us in the vastness of space. The vastness of our solar system, with its swirling gas giants and their captivating moons, invites us to ponder the delicate balance of conditions necessary for life. While much of our attention has been drawn to these intriguing celestial bodies, the nature of life itself, in its many possible forms, remains an ever-present question. Life, as we understand it, relies heavily on certain key elements: liquid water, a source of energy, and the right chemical ingredients. Yet, contemplating the infinite variety of environments across the universe, we must open our minds to the possibility that life might manifest in ways we have yet to imagine, adapting to environments that we, as terrestrial beings, might initially deem inhospitable. In this contemplative journey, our focus naturally gravitates towards the building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are elements that form the foundation of biological molecules on Earth. These elements, forged in the hearts of stars and scattered across the cosmos, are abundant in many of the planets and moons we explore. The discovery of complex organic molecules, for instance, in the plumes of Enceladus or in the atmosphere of Titan, hints at the tantalizing possibility that the basic ingredients for life are not unique to our planet. This realization invites us to consider the myriad ways in which these elements might combine under different conditions to give rise to life forms that are perhaps beyond our current comprehension. The search for life, then, is as much about understanding the fundamental chemistry of the universe as it is about exploring distant worlds. By studying the atmospheres, surfaces, and subsurface oceans of these celestial bodies, we glean insights into the processes that might support life. For example, the study of extremophiles on Earth, organisms that thrive in conditions we once thought too hostile for life, has expanded our understanding of life's resilience and adaptability. These organisms, found in the scalding hydrothermal vents of the deep ocean, the acidic pools of Yellowstone, or the frozen deserts of Antarctica, demonstrate that life is tenacious and can persist in environments with extremes of temperature, acidity, and radiation. As we extend our search for life beyond Earth, we must consider environments that challenge our preconceived notions of habitability. The gas giants, with their tumultuous atmospheres and intense pressure, present environments so extreme that any form of life would need to be radically different from anything we know. The crushing pressures and lack of a solid surface on these planets make the existence of life, as we know it, unlikely. However, some scientists have speculated about the possibility of life existing in the upper layers of these thick atmospheres, where conditions are less severe. If life could exist in such a realm, it might resemble nothing we have ever encountered, perhaps buoyant, floating organisms sustained by the chemical reactions within the clouds. While the direct study of the gas giants themselves poses significant challenges, their moons offer more accessible targets for exploration. The possibility of subsurface oceans, hidden beneath icy crusts and warmed by tidal forces, is particularly intriguing. Such environments could provide the stable conditions and chemical gradients necessary to support life. As we design missions to probe these hidden oceans, we must carefully consider how best to search for signs of life. Whether through the analysis of surface ice samples, the study of geysers and plumes, or the deployment of landers and submersibles, each approach brings us closer to unraveling the mysteries of these alien seas. In contemplating the potential for life on gas giants and their moons, we are reminded of the delicate interplay between science and philosophy. The search for extraterrestrial life is not merely an endeavor to answer a scientific question. It is a profound exploration of our place in the universe. Finding life elsewhere would challenge our understanding of biology and evolution, prompting us to reconsider the uniqueness of our own existence. It would raise questions about the universality of life and the potential for diverse forms of intelligence across the cosmos. Moreover, the ethical implications of discovering life beyond Earth are profound. If we were to find even the simplest form of life on another world, it would necessitate a reevaluation of our responsibilities as stewards of the universe. The preservation of extraterrestrial ecosystems, particularly those that might harbor life, would become a moral imperative. We would need to balance the drive for exploration and discovery with the duty to protect and preserve the sanctity of these environments. In doing so, we would affirm our commitment to respecting life in all its forms and ensuring that our search for knowledge does not come at the expense of the very worlds we seek to understand. As we continue to explore the potential for life on gas giants and their moons, we must also reflect on the technological advancements that make such exploration possible. The development of sophisticated spacecraft, capable of withstanding the harsh conditions of space and the environments of distant planets, has been a remarkable achievement. Technologies such as remote sensing, autonomous navigation, and advanced robotics allow us to study these distant worlds with unprecedented detail and precision. These advancements not only enhance our ability to search for life, but also expand our understanding of planetary systems and the processes that shape them. The study of gas giants and their moons also provides valuable insights into the formation and evolution of our solar system. By examining the composition and dynamics of these planets and their satellites, we can better understand the processes that led to the formation of planetary systems. This knowledge, in turn, informs our understanding of exoplanets, planets orbiting stars beyond our solar system, and the potential for habitable worlds elsewhere in the universe. The discovery of numerous exoplanets, some of which reside in the habitable zones of their stars, underscores the possibility that life could be widespread across the galaxy. As we ponder the potential for life on gas giants and their moons, we are reminded of the interconnectedness of all things in the universe. The atoms that make up our bodies were once part of ancient stars, and the elements that sustain life on Earth are shared with distant worlds. This cosmic kinship inspires a sense of wonder and humility as we recognize our place in the vast tapestry of existence. It challenges us to approach the universe with open minds and open hearts, ever mindful of the beauty and complexity of life in all its forms. In this spirit of curiosity and respect, we look to the future with hope and determination. The search for life beyond Earth is a journey that transcends borders and unites humanity in a shared quest for knowledge and understanding. As we continue to explore the cosmos, we must do so with a sense of purpose and responsibility, guided by the principles of exploration and preservation. The discoveries we make will not only deepen our understanding of the universe, but also enrich our appreciation of the preciousness of life on our own planet. In the quiet moments of reflection, let your thoughts drift gently across the vast expanse of the cosmos. Imagine the possibilities that await us among the stars, the myriad worlds that hold the secrets of life and the universe. Let this sense of wonder and awe guide you as you contemplate the infinite potential of the cosmos and the profound questions that lie at the heart of our exploration. The universe is a vast and mysterious place, full of beauty and wonder, and the journey to understand it is one of the most profound endeavors we can undertake. As we continue this journey together, may we do so with an open mind, a curious heart, and a deep respect for all that we discover. In contemplating the vast realms of possibility, we find ourselves drawn to the enigmatic nature of gas giants. These immense planets, with their swirling clouds and tempestuous atmospheres, invite us to ponder the nature of life itself. Jupiter, Saturn, Uranus, and Neptune, the titans of our solar system, each present unique environments that challenge our understanding of habitability. Yet they also offer a canvas upon which we might imagine life in forms that are fundamentally different from anything we know. As you consider these distant worlds, allow your mind to wander through the layers of atmosphere, where pressures and temperatures vary so greatly. In such extremes, life, if it exists, would need to adapt in ways we can scarcely imagine. The very idea stirs a deep curiosity within us. The thick atmospheres of these giants are primarily composed of hydrogen and helium, with trace amounts of methane, ammonia, and other simple compounds. Beneath the cloud tops, the pressures are immense, and temperatures can soar to extraordinary levels. This environment is hostile to life as we know it, yet it is not inconceivable that life, if present, might exploit chemical gradients and energy sources in ways that are unfamiliar to us. Here, the delicate play of chemistry could foster microscopic life forms, suspended in the turbulent skies, much like Earth's own airborne microbes that drift upon the winds. The moons that orbit these gas giants also captivate our imagination. Titan, Saturn's largest moon, with its dense, nitrogen-rich atmosphere and lakes of liquid methane and ethane, presents a landscape where life might arise in a form based on entirely different biochemistry. The presence of organic molecules suggests a world rich in the ingredients necessary for life, albeit life, that would operate on principles distinct from those on Earth. Similarly, Europa, with its icy shell concealing a vast subsurface ocean, offers a tantalizing possibility for life. Beneath the frozen crust, where warm, mineral-rich waters might interact with the rocky mantle, life could potentially thrive in conditions reminiscent of Earth's own deep-sea hydrothermal vents. The exploration of these moons requires technologies that push the boundaries of our current capabilities. Probes and landers designed to withstand extreme conditions must also be equipped with instruments to detect the subtle signs of life. The search for biosignatures, those telltale signs of biological processes, is a delicate endeavor. It involves scanning for specific gases, isotopic ratios, and complex organic molecules that might suggest the presence of living organisms. The challenge is immense, yet the potential rewards are profound, offering insights into the adaptability and resilience of life. As we broaden our scope beyond our solar system, we turn our gaze to the exoplanets orbiting distant stars. Among them, gas giants similar to Jupiter and Saturn are numerous. These distant worlds, detected by the subtle wobbles they induce in their parent stars, or by the dimming of starlight as they transit across their stellar hosts, expand our understanding of planetary systems and their potential for harboring life. While the atmospheres of these exoplanets remain largely mysterious, advances in telescopic technology promise to unveil their compositions and potentially their habitability. The study of gas giants and their potential for hosting life challenges us to rethink the very nature of living systems. It invites us to consider forms of life that are not carbon-based, perhaps utilizing silicon or ammonia as a solvent. Such speculation, while grounded in the principles of chemistry and physics, stretches our imagination to its limits. It reminds us that life, in its infinite adaptability, may find a way to flourish in the most unexpected of places. As we continue to explore these distant worlds, we do so with a spirit of respectful curiosity. The discovery of extraterrestrial life, if it occurs, will undoubtedly reshape our understanding of the universe and our place within it. It will prompt profound philosophical reflections on the nature of life and consciousness, and the interconnectedness of all living things. In this journey, we are guided by a desire to understand the fundamental processes that govern life, to uncover the universal principles that underpin biological systems, and to appreciate the diversity of forms that life might take. The pursuit of knowledge is a journey without end, a voyage that takes us beyond the confines of our home planet and into the vast expanse of the cosmos. It is a quest that requires patience and perseverance, a willingness to embrace the unknown and to confront the mysteries that lie before us. As we delve deeper into the secrets of the universe, let us do so with a sense of humility and awe, recognizing the beauty and complexity of the world around us. The universe is a tapestry of wonders, each thread woven with the intricate patterns of life, and it is our privilege to explore its depths with an open heart and a curious mind. In this grand exploration, we are not alone. We are joined by generations of thinkers and dreamers, scientists and explorers, whose collective efforts have brought us to this moment in time. Together, we seek to unravel the mysteries of the cosmos, to understand the origins and evolution of life, and to contemplate the possibility of life beyond our earthly confines. It is a journey that binds us together, a shared endeavor that transcends borders and cultures, uniting us in a common pursuit of knowledge and understanding. As you reflect on these vast possibilities, allow yourself to be enveloped by the gentle wonder of the universe. Consider the myriad ways in which life might manifest itself, and the profound implications of discovering life beyond Earth. In this quiet contemplation, we find a connection to the cosmos, an understanding that we are part of something much greater than ourselves. The universe is a vast and mysterious place, full of beauty and wonder, and the journey to understand it is one of the most profound endeavors we can undertake. May we continue to explore with an open mind, a curious heart, and a deep respect for all that we discover. In the vast and profound silence of the cosmos, where the light of countless stars glimmers softly against the inky backdrop of space, the question of life on gas giants beckons us to imagine possibilities beyond the boundaries of our familiar terrestrial existence. These colossal planets, with their swirling atmospheres and immense gravitational forces, present environments that stretch our understanding of habitability. Yet within their turbulent skies, there lies a whisper of potential, a hint that life, in some form, might find a way to thrive amidst the chaos. The concept of life emerging in such inhospitable places invites us to redefine our notions of what living systems might look like, and how they could adapt to conditions far removed from those on Earth. The gas giants, with their thick, impenetrable clouds and powerful storms, possess atmospheric layers that vary widely in temperature and pressure. Within these stratified realms, the interaction of chemistry and physics creates a dynamic environment where complex molecules can form. The notion that life could exist in such a place is supported by the presence of organic compounds, detected in the atmospheres of Jupiter and Saturn. These molecules provide the foundational building blocks for life as we know it, suggesting that the initial ingredients for biological processes are present. The potential for life also hinges on the presence of energy sources, as life requires energy to sustain itself. On gas giants, this energy could come from the planet's internal heat, the sun's radiation, or the chemical energy generated by lightning and other atmospheric phenomena. In this layered atmosphere, some scientists speculate about the presence of floating microbial life forms, perhaps akin to the extremophiles on Earth that thrive in high-altitude clouds or acidic environments. These hypothetical organisms could drift in the relatively temperate upper layers of the atmosphere, where conditions might be conducive to sustaining life. In this gentle dance between the forces of nature, life's resilience is demonstrated, revealing an adaptability that knows few bounds. As we contemplate such life forms, we are reminded of the tenacity of life on Earth, which has found niches in the most unexpected and extreme environments, from the crushing depths of the ocean to the arid expanses of deserts. The exploration of gas giants and their potential to harbor life is not solely bound to our immediate cosmic neighborhood. Beyond the solar system, the search for exoplanets has revealed a diverse array of worlds, some of which bear a resemblance to our own gas giants. These distant planets, orbiting stars light years away, expand our understanding of planetary systems and the conditions under which life might arise. The detection of exoplanets with atmospheres rich in hydrogen and helium, similar to those of Jupiter and Saturn, suggests that the processes we observe in our solar system may be mirrored across the galaxy. The study of these distant worlds is a testament to the ingenuity of human curiosity, as we develop increasingly sophisticated technologies to probe the skies and capture the faintest signals from these distant realms. In contemplating the possibility of life on gas giants, we are also drawn to consider the role of liquid water, a crucial ingredient for life as we understand it. While gas giants themselves may not harbor liquid water in the traditional sense, their moons present intriguing possibilities. Moons such as Europa and Enceladus, with their subsurface oceans hidden beneath icy crusts, offer environments where life could potentially flourish, shielded from the harsh conditions of space. The discovery of water plumes erupting from the surface of Enceladus, spewing organic-rich material into space, provides tantalizing evidence of active geological processes and the possibility of habitable environments beneath the ice. As we extend our gaze to the outer reaches of our solar system and beyond, the diversity of planetary bodies challenges us to rethink the constraints of habitability. The notion of life based on alternative biochemistries, perhaps utilizing solvents other than water, opens new avenues for exploration. On Titan, Saturn's largest moon, the presence of liquid methane and ethane lakes raises the possibility that life could employ a different set of chemical processes, forging a path divergent from our carbon-water paradigm. These considerations push the boundaries of our imagination, inviting us to envision life forms that operate under entirely different principles, yet still share the fundamental drive to sustain and propagate. The exploration of gas giants and their potential for life is a journey not only of scientific discovery, but also of philosophical reflection. It prompts us to ponder the nature of life itself, encouraging us to question the very definitions that we hold. In seeking life beyond Earth, we are driven by a desire to understand our place in the cosmos, to connect with the larger tapestry of existence. This quest is a reminder of the interconnectedness of all things, a realization that even in the vast solitude of space, we are never truly alone. The universe, in all its complexity and magnificence, is a shared heritage, and the pursuit of knowledge is a collective endeavor that unites us in our common humanity. As we continue to explore the potential for life on gas giants, we are guided by the principles of scientific inquiry and the ethical considerations that accompany such exploration. The search for extraterrestrial life is a delicate endeavor, requiring respect for the unknown and an awareness of the impact of our actions. As we reach out to the stars, it is imperative that we do so with a sense of stewardship, mindful of the environments we seek to understand. The discovery of life in any form would be a profound moment in human history, reshaping our understanding of biology, our place in the universe, and the very nature of life itself. In this quiet contemplation of the cosmos, we find a reflection of our own existence, a mirror that invites us to look beyond the confines of our world and embrace the wonder of the unknown. The journey to discover life on gas giants, and indeed throughout the universe, is a testament to the boundless curiosity of the human spirit. It is an exploration that transcends the boundaries of science, touching on the philosophical and the spiritual, as we seek to understand not only the universe around us, but also the essence of life itself. Through this exploration, we are reminded of the beauty and intricacy of the cosmos, a reminder that in our quest for knowledge, we are part of something far greater than ourselves. As you listen to the gentle musings about the possibility of life on gas giants, allow yourself to ponder the vastness of space and the myriad of possibilities it holds. Imagine the intricate dance of molecules within the swirling clouds of a distant planet, the potential for life to take root in even the most unlikely of places. This quiet reflection invites you to consider the interconnectedness of all things, the shared journey of exploration that unites us in our quest for understanding. As we gaze into the cosmos, we are reminded of the infinite possibilities that await discovery, each one a testament to the wonder and beauty of the universe. As we continue to ponder the vastness of the cosmos and the potential for life in the most unexpected of realms, our attention turns to the intricate and delicate balance that governs the atmospheres of gas giants. These colossal planets, with their thick gaseous envelopes, present a dynamic tapestry of chemical reactions and atmospheric processes that are as captivating as they are complex. Within the roiling clouds of Jupiter or the serene, ringed beauty of Saturn, we find a symphony of elements dancing in a perpetual state of flux. Imagine the interplay of hydrogen and helium, the most abundant elements in their atmospheres, weaving together with traces of ammonia, methane, and water vapor. This chemical ballet, driven by intense pressures and temperatures, creates an environment that, while inhospitable to life as we know it, challenges our imaginations to envision alternative forms of existence. Consider the upper layers of these atmospheres, where the interplay of light and matter crafts a realm of perpetual twilight. Here, the sun's rays, weakened but ever-present, mingle with the gaseous expanse, creating an environment that might just support life forms uniquely adapted to such conditions. Picture microscopic organisms, adrift on the winds, drawing energy not from the sun in the way familiar to us, but from the chemical energy abundant in their surroundings. The concept of life thriving under such alien circumstances invites us to consider the diversity of potential life forms, each uniquely adapted to its cosmic niche. Turning our gaze outward, the exploration of gas giants extends beyond our solar system, where exoplanets of similar composition pique our curiosity. These distant worlds, orbiting stars far removed from our own, expand the horizon of our search for life. In recent years, advances in astronomical technology have allowed us to detect their presence and study their atmospheres from afar. The discovery of gas giants in other star systems, some with conditions akin to or even more extreme than those found in our neighborhood, presents tantalizing prospects. Within their vast atmospheres, the potential for life, or at least the precursors to life, exists as a whisper in the cosmic winds, urging us to look closer, to listen harder. In this grand cosmic context, the role of moons becomes particularly intriguing. Moons, often overlooked in favor of their more imposing planetary hosts, offer a different perspective on habitability. Take, for instance, Titan, the largest moon of Saturn, with its thick, hazy atmosphere and rivers of liquid methane. Titan serves as a natural laboratory, a place where organic chemistry occurs on a scale and complexity unmatched elsewhere. Here, the absence of liquid water, traditionally seen as a prerequisite for life, is replaced by the abundance of hydrocarbons, prompting us to consider life forms based on alternative biochemistries. Could life, in some form, thrive in such a setting, evolving to utilize methane in a way that parallels our own reliance on water? Such questions, though speculative, inspire us to broaden our definitions of life and habitability. In contemplating the potential for life on gas giants and their moons, we also delve into the concept of panspermia, the idea that life, or at least the building blocks of life, can be transported across the cosmos. This theory suggests that comets, asteroids, or even planetary collisions could carry the seeds of life from one celestial body to another, spreading it across vast distances. The harsh environments of gas giants and their moons could then serve as melting pots, where these ingredients come together in new and unexpected ways. Imagine the possibilities if life's origin is not isolated to a single world, but is instead a shared cosmic heritage, scattered among the stars. The search for life on gas giants also leads us to consider the role of technology in our quest for understanding. The tools and instruments we develop, from powerful telescopes to space probes, act as extensions of our senses, allowing us to peer deeper into the universe than ever before. Missions like Juno, orbiting Jupiter, and Cassini, which explored the Saturnian system, have provided us with invaluable data, expanding our knowledge and fueling our curiosity. As technology advances, so too does our ability to explore these distant worlds, to probe their atmospheres, and to seek out signs of life. In the quiet solitude of space, amidst the swirling clouds and turbulent storms of gas giants, lies a reminder of the interconnectedness of all things. The quest to understand these distant worlds is a reflection of our own desire to comprehend the universe and our place within it. Each discovery, each revelation, brings us one step closer to answering the age-old question: are we alone in the cosmos? As we continue to explore, to dream, and to seek out life in its myriad forms, we are united in a shared journey of discovery. The cosmos, with its infinite possibilities, invites us to keep looking up, to keep wondering. It is a canvas painted with the colors of possibility, a testament to the beauty and complexity of existence. In our pursuit of knowledge, we find not only answers but also a deeper understanding of ourselves and the world around us. As we contemplate the potential for life on gas giants and their moons, we are reminded that the universe is vast and its mysteries are boundless. Each new discovery is a step forward in our collective journey, a reminder that the quest for understanding is as infinite as the stars themselves. So let us continue to explore, to imagine, and to seek out the unknown. In doing so, we find not only the potential for life in the most unexpected of places, but also a greater appreciation for the wonder and beauty of the universe. And as we gaze into the night sky, filled with stars and possibilities, we are reminded that the journey of exploration is one that never truly ends. It is a journey that invites us to dream, to question, and to embrace the endless possibilities of the cosmos. As we journey further into the vast expanse of space, we find ourselves drawn to the mysterious allure of gas giants, those majestic behemoths that dominate their planetary neighborhoods with their immense gravity and swirling atmospheres. These colossal planets, such as Jupiter and Saturn in our own solar system, offer a tantalizing glimpse into the complexity and diversity of celestial bodies. While the concept of life as we know it grappling with the harsh conditions on these giants seems challenging, the universe often surprises with its resilience and adaptability. The thick layers of clouds and tumultuous storms that characterize these planets conceal a world of potential beneath their shrouded surfaces. It is here that scientists hypothesize about the possibilities of life, not as we traditionally understand it, but in forms that might thrive in the extreme pressures and volatile chemical cocktails found within these atmospheres. The notion of life existing in the dense, gaseous layers of a planet is not confined to mere speculation, but is grounded in the adaptability of life to thrive in extreme environments. Extremophiles on Earth, those remarkable organisms that flourish in conditions once deemed inhospitable, have broadened our understanding of life's potential habitats. These resilient forms of life, found in the depths of our oceans and the cracks of volcanic vents, challenge our perceptions and expand the boundaries of where life could exist beyond our planet. Their existence hints at the possibility that life on a gas giant, if it exists, may not rely on the same biochemical processes that sustain life on Earth. Instead, it might harness chemical energy, such as the rich methane and ammonia present in these alien environments, to sustain itself in ways we have yet to fully comprehend. In exploring the atmospheres of gas giants, we are also reminded of the delicate balance of conditions that support life. These planets exhibit a complex interplay of atmospheric dynamics, with powerful winds and storms that dwarf even the most severe weather patterns on Earth. The Great Red Spot on Jupiter, a storm larger than our entire planet, has raged for centuries, a testament to the dynamic forces at play in such atmospheres. Within this ever-changing environment, any form of life would need to be incredibly adaptable, capable of surviving the rapid shifts in temperature and pressure. Such adaptability might manifest in organisms that are buoyant, floating within the layers of gas, or perhaps clinging to the wisps of clouds that traverse these alien skies. Beyond our solar system, the search for life on gas giants extends to the myriad exoplanets that orbit distant stars. With each new discovery, our understanding of the universe's diversity deepens. Among these exoplanets, we find gas giants that challenge our imagination, with some boasting atmospheric compositions unlike anything we have encountered before. The study of these distant worlds, through the lens of powerful telescopes and advanced technology, offers a unique opportunity to compare and contrast with our own solar system's giants. Each observation adds a piece to the puzzle, helping us to piece together a broader picture of how life might arise and persist in such extraordinary circumstances. As we continue to refine our tools and techniques for observing these distant worlds, we are guided by the principles of chemistry and physics that govern planetary atmospheres. Spectroscopy, the study of how light interacts with matter, allows us to peer into the atmospheres of these planets, revealing their composition and hinting at the processes occurring within. By analyzing the light that filters through a planet's atmosphere as it passes in front of its star, we can detect the presence of gases that might hint at biological activity. This technique, still in its infancy, holds the promise of uncovering the secrets of these distant giants, and perhaps even the subtle signs of life. In contemplating the possibility of life on gas giants, we are also reminded of the interconnectedness of all things within the universe. The elements that form the building blocks of life are forged in the hearts of stars, dispersed across the cosmos in the explosive deaths of these celestial bodies. This cosmic recycling of matter weaves a tapestry of life that spans galaxies, linking us to the stars and to the potential life that may dwell on distant worlds. It is a humbling thought, this notion that the atoms within us once danced in the cores of ancient stars, and that the same elements might give rise to life in the most unexpected of places. The exploration of gas giants and the search for life therein also challenges us to consider the ethical implications of our quest. As we peer into the depths of these planets and ponder their secrets, we are reminded of our responsibility to approach the cosmos with humility and respect. The potential discovery of life beyond Earth raises profound questions about our place in the universe and the ethical considerations of our interactions with other forms of life. It is a call to reflect on the impact of our technological advancements and to ensure that our exploration is guided by principles of stewardship and care. As we navigate the vastness of space, we are supported by the remarkable achievements of scientists and engineers who strive to unlock the mysteries of the universe. The missions that probe the depths of our solar system and beyond are a testament to human ingenuity and the spirit of exploration. These efforts are not just scientific endeavors, but also acts of collective imagination, driven by the desire to understand our place in the cosmos. Each mission, each discovery, adds to the rich tapestry of knowledge that stretches across generations, a legacy of curiosity and wonder that propels us forward. In the quiet moments of reflection, as we contemplate the vastness of the universe and the possibilities it holds, we are reminded of the beauty and fragility of our own planet. Earth, a small blue dot in the vast cosmic ocean, is our home and the cradle of all known life. It is a sanctuary that supports a delicate balance of ecosystems and a rich diversity of life forms. In our quest to explore the universe, we are called to cherish and protect this precious world, to ensure that future generations can continue to gaze up at the stars with wonder and curiosity. As we draw these contemplations to a gentle close, let us carry with us the sense of awe and reverence that the cosmos inspires. The universe, in all its vastness and complexity, invites us to explore, to learn, and to dream. It challenges us to expand the horizons of our understanding and to embrace the infinite possibilities that lie beyond the stars. In this journey, we find not only the potential for life in the most extraordinary of places, but also a deeper connection to the universe and to each other. As we continue to explore, Let us do so with open hearts and minds, guided by the light of discovery and the spirit of exploration. Reflecting upon the vast canvas of the cosmos, we find ourselves drawn to the enigmatic gas giants, these colossal behemoths of swirling clouds and tempestuous storms, as they stand sentinel in the outer reaches of our solar system. Each one, with its distinct personality and complex atmospheric dynamics, beckons us to ponder the possibilities of life in forms and scales unimaginable. As we cast our gaze upon Jupiter, the largest of them all, we are met with a world dominated by turbulent winds and the mesmerizing dance of its great red spot, a storm that has raged for centuries, if not millennia. Here, in this swirling mass of hydrogen and helium, the prospect of life as we know it seems remote, yet the very extremity of this environment invites us to question the limits of habitability. Yet it is not always the planets themselves that capture our imagination, but rather their moons, those celestial bodies that orbit in their shadow, harboring secrets of their own. Around Jupiter we discover Europa, a moon cloaked in ice, its surface crisscrossed with cracks and ridges, hinting at a vast ocean beneath. This subsurface ocean, kept warm by the gravitational embrace of its host planet, becomes a tantalizing target in the search for life beyond Earth. The potential for hydrothermal vents on its ocean floor, akin to those found in the depths of Earth's oceans, suggests a habitat where life could thrive, fueled by the energy and nutrients released from the moon's interior. Venturing further into the solar system, Saturn's moon Enceladus presents another intriguing possibility. This small, icy moon reveals its secrets through the geysers that erupt from its south pole, spewing water vapor and organic compounds into space. These plumes, detected by spacecraft passing by, provide a glimpse into the ocean beneath Enceladus's icy shell, a world where the conditions might mirror those of primordial Earth. Here, in these hidden depths, the building blocks of life could be assembling, awaiting the spark of creation. The exploration of gas giants and their moons is not merely a quest for life, but a journey into the unknown, where each discovery challenges our understanding of biology and chemistry. As we contemplate the potential for life in these alien seas, we are reminded of the resilience of life on Earth, the myriad ways it has adapted to thrive in the most inhospitable environments. This resilience inspires us to imagine new forms of life that could exist in the icy darkness of Europa's ocean, or within the high-pressure depths of Jupiter's atmosphere. In our search, we employ the tools of science, ever advancing and refining, to peer into these distant worlds. Spectroscopy, as mentioned, allows us to analyze the light reflected and absorbed by their atmospheres, revealing the complex interplay of gases and chemicals that might signal the presence of biological processes. The advancement of technology enables us to send forth robotic emissaries, spacecraft designed to withstand the harshness of space, to orbit, to land, and to probe the mysteries of these distant realms. With each mission, we gather data, piecing together the story of these worlds, and in doing so, deepen our appreciation for the diversity of planetary environments. As we ponder the potential for life on gas giants and their moons, we are drawn to consider the broader implications of such a discovery. The confirmation of life beyond our planet would be a profound moment in the history of science and humanity, reshaping our philosophical and existential understandings. It would prompt us to reevaluate our place in the cosmos, to consider the possibility of other civilizations, and to reflect on the nature of life itself, its origins, and its universality. The allure of space exploration extends beyond the scientific, touching upon the spiritual and the poetic. The night sky, with its tapestry of stars and planets, has long inspired artists, writers, and dreamers, serving as a canvas for the imagination. The stories we tell, the myths we create, are reflections of our desire to connect with the universe, to find meaning in the vastness that surrounds us. In this sense, the search for life on gas giants and their moons becomes a narrative of wonder and possibility, a journey that transcends the boundaries of science and enters the realm of human experience. In our quest to understand the universe, we are guided by the principles of exploration and discovery, driven by a curiosity that knows no bounds. This quest is not without its challenges, as the exploration of space requires immense resources, both technological and human. It calls for international collaboration and a commitment to the peaceful pursuit of knowledge. As we reach for the stars, we must also look inward, considering the ethical dimensions of our exploration, ensuring that our actions are guided by respect for the environments we study and for the potential life forms we may encounter. The exploration of gas giants and their moons is a testament to human ingenuity and perseverance. It is a reminder of our capacity to dream, to imagine what lies beyond the horizon, and to strive towards those dreams with determination and purpose. As we continue to explore these distant worlds, we do so with the hope that one day we will find the answers to the questions that have long captivated our species. Are we alone in the universe? What forms might life take in the diverse environments of other planets and moons? And how does our existence fit into the grand tapestry of the cosmos? In contemplating these questions, we embark upon a journey that is as much about discovery as it is about reflection. The search for life on gas giants and their moons encourages us to look back at our own planet, to appreciate the delicate balance that sustains life here, and to recognize the interconnectedness of all living things. It serves as a reminder of the fragility of life and the importance of safeguarding our own world, even as we set our sights on others. The exploration of space, with its challenges and possibilities, is a journey that requires both patience and persistence. It encourages us to embrace the unknown, to venture beyond the familiar, and to remain open to the unexpected. In this journey, we find not only the potential for life in the most extraordinary of places, but also a deeper connection to the universe and to each other. As we continue to explore, let us do so with open hearts and minds, guided by the light of discovery and the spirit of exploration. In the stillness of the night, as you reflect on the vastness of the universe, think of the gas giants and their moons, the mysteries they hold, and the potential for life that awaits discovery. Imagine the possibilities that lie within the swirling clouds of Jupiter, the icy depths of Europa, and the geysers of Enceladus. Let your thoughts drift across the cosmos, carried by the gentle whisper of the stars, as you contemplate the wonders that await us in the vast expanse of space. With each passing moment, our understanding of the universe expands, revealing new insights and opening new avenues for exploration. The search for life on gas giants and their moons is just one part of this larger journey, a journey that calls us to look beyond the boundaries of our own world and to embrace the infinite possibilities that lie beyond. As we continue to explore, may we do so with a sense of wonder and curiosity, ever mindful of the beauty and complexity of the universe we inhabit. Such is the nature of our cosmic quest, an unending voyage that propels us ever deeper into the heart of the universe's mysteries. As we traverse these vast expanses, our gaze inevitably turns to the majestic gas giants, colossal worlds that float serenely in the velvet darkness, their swirling atmospheres concealing secrets that beckon to us with quiet insistence. These titans of our solar system, with their immense gravitational pulls, are more than mere behemoths of gas and pressure. They are intricate systems, with layers of complexity that challenge our understanding and stir our imagination. The allure of gas giants lies not only in their grandeur, but also in their potential to reshape our conception of where life might find a foothold. As we ponder their swirling clouds and hidden depths, we consider the possibility that life, in some form, might find a niche within these turbulent atmospheres. The notion seems almost fantastical at first glance. How could life possibly endure in such harsh and volatile environments? Yet nature has a way of surprising us, of finding pathways and niches in the most unlikely of places. The gas giants, with their towering storms and winds, present a canvas upon which life might paint itself in ways we have yet to envision. It is within the layers of these gas giants that we find an intriguing possibility: the concept of aerial life forms, floating freely within the thick, tempestuous atmospheres. Could there exist organisms that drift upon the currents, akin to Earth's plankton riding on the ocean waves? Such life would need to be extraordinarily adapted, capable of withstanding the intense pressures and volatile chemistry that define these worlds. While no direct evidence of such life has yet been discovered, the hypothesis serves as a reminder of the boundless creativity inherent in nature's designs. In contemplating life on gas giants, we must also consider the unique chemistry that characterizes these planets. Rich in hydrogen and helium, with traces of methane, ammonia, and water vapor, these atmospheres present a rich tapestry of chemical interactions. It is within this dynamic environment that life, if it exists, might exploit chemical gradients and energy sources that remain inaccessible to us. Our understanding of extremophiles on Earth, organisms that thrive in conditions once thought inhospitable, fuels our curiosity and opens our minds to the myriad possibilities that lie hidden beneath the swirling clouds. As our technological prowess grows, so too does our ability to probe these distant worlds with greater precision and depth. The space probes that venture into the reaches of our solar system carry with them the hopes and dreams of humanity, each one a messenger dispatched to gather whispers from the cosmos. Instruments aboard these spacecraft, such as spectrometers and cameras, capture data that reveal the composition and behavior of planetary atmospheres, providing us with the clues needed to piece together the puzzle of potential life. The exploration of gas giants is not merely an exercise in scientific curiosity, but a profound reflection on our place in the universe. As we seek to understand the conditions that might support life, we are invariably drawn to reflect on the fragility and tenacity of life on Earth. Our planet, with its delicate balance of ecosystems and climates, serves as both a sanctuary and a benchmark for our explorations. It is from this vantage point that we gaze outward, contemplating the myriad forms life might take and the environments it might call home. In this grand exploration, we are reminded of the interconnectedness of all things, the way in which the dance of celestial bodies shapes the destiny of worlds. The gas giants, with their retinues of moons and rings, influence the gravitational ballet that defines our solar system. Their presence is felt in the orbits of comets and asteroids, in the tides of distant moons, and perhaps even in the genesis of life itself. As we unravel the mysteries of these worlds, we deepen our understanding of the forces that have shaped our own planet and the conditions that have permitted life to flourish. Beyond the scientific and philosophical implications, the exploration of gas giants offers a profound opportunity for collaboration and unity. The challenges inherent in venturing to these distant realms necessitate a pooling of resources, knowledge, and expertise on a global scale. Scientists and engineers from around the world come together to design missions, analyze data, and interpret findings, united by a common goal of expanding our understanding of the universe. This spirit of collaboration transcends borders and cultures, reminding us of the shared human quest for knowledge and discovery. As we look to the future, the prospect of deeper exploration of gas giants and their moons beckons with promises of discovery and insight. Perhaps one day, we will send probes capable of diving into the thick atmospheres of planets like Jupiter and Saturn, equipped with advanced instruments designed to sample the chemical soup and search for signs of life. These missions, while ambitious, are within the realm of possibility, and each step forward brings us closer to unlocking the secrets of these enigmatic worlds. In dreaming of these future explorations, we also consider the ethical dimensions of our quest. The search for life, while exhilarating, carries with it a responsibility to preserve and protect the environments we seek to understand. It is imperative that our exploration be guided by principles of stewardship and respect, ensuring that our actions do not inadvertently harm the very ecosystems we are attempting to study. As we traverse the cosmos, we must remain mindful of our role as caretakers, committed to preserving the integrity and beauty of the universe we inhabit. The gas giants, with their grandeur and mystery, serve as a reminder of the vast expanse of the universe and the infinite possibilities it holds. They challenge us to expand our horizons, to question our assumptions, and to embrace the unknown with a spirit of wonder and curiosity. As we continue our journey, we do so with the knowledge that each discovery brings us closer to understanding the tapestry of life and the universe itself. In the stillness of the night sky, the gas giants stand as silent sentinels, watching over the cosmic dance of planets and stars. They beckon us to venture forth, to explore their secrets, and to reflect on the profound interconnectedness of all things. As we heed their call, we are reminded of the beauty and complexity of the universe, a universe that invites us to dream, to explore, and to cherish the delicate balance of life in all its forms. With each step we take, we continue the timeless journey of discovery, ever mindful of the wonders that await us in the vast, uncharted territories of space. The gas giants, with their swirling clouds and hidden depths, are but one chapter in the story of our exploration, a story that unfolds with each new discovery and each new insight. As we venture further into the cosmos, may we do so with a sense of humility and awe, forever inspired by the mysteries and marvels that lie beyond the horizon. In contemplating the vastness of space, our gaze often drifts toward the gas giants, those enigmatic behemoths that orbit our sun with silent majesty. These celestial bodies, while seemingly inhospitable at first glance, whisper of secrets cloaked beneath their turbulent atmospheres. As we muse on the potential for life in such alien realms, we find ourselves drawn into a deeper understanding of what it means to exist within the universe. Life, in its myriad forms, has proven adaptable and resilient on our own planet, thriving in environments once thought too extreme. This adaptability encourages contemplation of life's potential beyond Earth, where conditions differ so radically from our own. The gas giants, Jupiter and Saturn, present environments of extremes, where colossal storms rage and atmospheric pressures reach unfathomable depths. Yet beneath these tempestuous layers, some scientists speculate about the possibility of life, not on the planets themselves, but perhaps within their moons or in the upper layers of their atmospheres. These musings, grounded in the scientific study of astrobiology, invite us to consider the vastness of life's potential adaptations. On Earth, we observe extremophiles, organisms that thrive in conditions of extreme heat, pressure, and acidity, suggesting that life, if it exists elsewhere, might find ways to flourish in places we have yet to fully understand. As we explore these possibilities, our thoughts naturally extend to the moons that accompany these giants. Europa, orbiting Jupiter, is a world encased in ice, beneath which lies an ocean of liquid water. This hidden sea, kept warm by the gravitational interactions with its massive host, stirs the imagination with visions of life that might exist in its dark, alien depths. Similarly, Saturn's moon, Enceladus, offers another tantalizing prospect with its geysers that spew plumes of water vapor into space, hinting at a subsurface ocean teeming with potential. These moons, with their icy surfaces and mysterious subsurface oceans, become focal points for our quest to find life beyond Earth. The instruments aboard our space probes have provided tantalizing glimpses into these worlds, capturing data that suggest the presence of organic molecules and energy sources, key ingredients for life as we know it. These findings, though preliminary, illuminate the path for future missions, each one designed to peel back another layer of mystery, revealing the secrets these moons may hold. In this grand tapestry of exploration, we find ourselves contemplating the complex chemistry and physical processes that might allow life to arise in such alien environments. The study of astrobiology challenges us to broaden our understanding of life's potential forms and adaptations. It encourages us to question the very nature of life itself, to redefine what it means to be alive in a universe that is vast and varied beyond our current comprehension. The very act of exploring these distant worlds underscores the interconnectedness of our own earthly existence with the greater cosmic ecosystem. The processes that shape the gas giants and their moons are, in many ways, echoes of the forces that have shaped our own planet. The interplay of gravity, chemistry, and time weaves a narrative that connects us to the farthest reaches of our solar system, reminding us that we are but a small part of a much larger story. In this story, our role as explorers is both a privilege and a responsibility. The data we gather, the discoveries we make, and the questions we ask are all part of a collective effort to understand the universe and our place within it. Each mission, each probe sent into the void, is a testament to human curiosity and ingenuity, a beacon of our desire to know more, to see further, and to understand deeper. As we ponder these distant worlds, we are reminded of the delicate balance that sustains life on Earth. The conditions that allow us to thrive are the result of countless cosmic coincidences, a finely tuned orchestra of elements and forces that have come together to create the world we know. This awareness brings with it an appreciation for the fragility and preciousness of life, encouraging us to approach our explorations with care and respect. Our journey to understand the potential for life on gas giants and their moons is still in its infancy. The questions we ask today will guide the explorations of tomorrow, leading us to new realms of discovery and understanding. As we stand on the cusp of these new frontiers, we do so with a sense of humility, aware of the vast unknowns that lie ahead. In this pursuit, the collaboration among scientists, engineers, and thinkers from around the world is crucial. The exchange of ideas and the sharing of knowledge transcend borders, uniting us in a common goal to explore and understand. This spirit of collaboration is a reminder of our shared humanity and our collective desire to reach beyond the familiar, to seek out the mysteries of the cosmos with open minds and open hearts. The exploration of gas giants and their moons is a journey that will take us deep into the unknown, pushing the boundaries of our understanding and challenging our perceptions of life itself. As we continue this journey, we are guided by a sense of wonder and curiosity, driven by the desire to uncover the secrets of the universe and to find our place within it. In this vast and uncharted territory, the possibilities are as endless as the stars. Each new discovery, each new insight, brings us one step closer to understanding the cosmos and our role within it. As we look to the future, we do so with hope and determination, inspired by the mysteries that await us in the far reaches of space. With each passing moment, the universe reveals itself to us in ways both profound and subtle, inviting us to delve deeper into its wonders. The gas giants, with their swirling clouds and hidden depths, are but one chapter in this grand narrative. As we continue to explore, we remain ever mindful of the beauty and complexity of the cosmos, inspired by the knowledge that there is always more to discover, more to learn, and more to understand. In this journey of discovery, we are reminded of the importance of preserving the delicate balance that allows life to flourish. The cosmos, in its vastness, teaches us that we are part of something much greater than ourselves, a reminder of the interconnectedness of all things. As we explore the universe, we do so with a sense of responsibility, aware of the impact of our actions and the legacy we leave for future generations. The exploration of gas giants and their moons is a testament to the enduring spirit of human curiosity and the quest for knowledge. It is a journey that challenges us to look beyond the familiar, to question the unknown, and to embrace the mysteries of the cosmos with open hearts and open minds. As we continue this journey, we do so with a sense of wonder and awe, inspired by the beauty and complexity of the universe and the endless possibilities that lie ahead. In the quiet moments of reflection, we find solace in the knowledge that our exploration of the cosmos is a journey without end, a testament to the boundless potential of human imagination and the enduring quest to understand the universe and our place within it. As we look to the stars, we are reminded of the power of curiosity and the importance of exploration. The journey is long, and the path is uncertain, but with each step we take, we move closer to unraveling the mysteries of the universe and finding our place within it. Beyond the swirling clouds and tempestuous atmospheres of the gas giants, our gaze shifts to the broader canvas of the solar system, where a tapestry of celestial objects weaves a story as old as time itself. In this cosmic ballet, each planet, moon, and asteroid plays a role in the grand narrative of creation and transformation. The gas giants, with their immense gravitational influence, shape the orbits of countless objects, acting as both protectors and sculptors of the solar system's architecture. Their powerful gravitational fields capture and deflect comets and asteroids, sometimes sending them hurtling towards the inner planets, yet often acting as a shield, preventing potential calamities from reaching Earth. It is within this delicate dance that we find the ingredients necessary for life as we know it, scattered like cosmic seeds across the vast expanse. Among these seeds are the complex organic molecules that form the building blocks of life. The discovery of such molecules in the atmospheres of gas giants and their moons hints at the tantalizing possibility that life, in some form, might exist in the most unexpected of places. These molecules, formed in the crucible of stellar evolution, are carried on cosmic winds and deposited on the surfaces of planets and moons, where they might one day coalesce into something more. The study of these molecules provides a window into the processes that might have led to the emergence of life on Earth, and by extension, elsewhere in the universe. As we peer through this window, we see a reflection of our own beginnings, a reminder of the intricate web of connections that binds us to the cosmos. The exploration of gas giants and their moons is not only a scientific endeavor, but also a philosophical one, challenging us to redefine our understanding of life and its potential manifestations. While the conditions on the surface of these planets are inhospitable by earthly standards, the vast, dense atmospheres and the hidden oceans beneath icy crusts offer environments where life might find a foothold. In these alien worlds, life might not resemble anything we are familiar with. It could be based on entirely different chemistries and processes. Our search for life in such environments expands our definition of what it means to be alive, pushing the boundaries of biology and inspiring new ways of thinking about life itself. The ongoing exploration of these distant realms is a testament to human ingenuity and the relentless pursuit of knowledge. Missions like the Galileo Orbiter, Cassini-Huygens, and the Juno probe have provided invaluable data, painting a more detailed picture of the outer solar system than ever before. The knowledge gleaned from these missions fuels our imagination and informs the design of future explorations, such as the Europa Clipper and the Dragonfly mission to Titan. These missions are poised to delve deeper into the mysteries of these icy moons, seeking signs of life and unraveling the processes that shape their environments. Each mission represents a leap forward in our understanding, a step closer to answering some of the most profound questions about our place in the universe. As we continue our journey, it is important to reflect on the interconnectedness of all things. The exploration of gas giants and their moons is not an isolated pursuit, but part of a larger quest to understand the cosmos and our place within it. The insights gained from studying these distant worlds have implications not only for our understanding of the universe, but also for our stewardship of our own planet. By exploring the extremes of the solar system, we gain a deeper appreciation for the fragile balance that sustains life on Earth. This awareness underscores the importance of preserving our planet and the delicate ecosystems that support life in all its forms. Moreover, the quest to explore the outer reaches of our solar system inspires a sense of unity and collaboration among nations. The challenges of space exploration transcend borders and politics, reminding us that we are all part of a larger whole. The shared goal of uncovering the secrets of the universe fosters a spirit of cooperation and mutual respect, encouraging us to work together for the betterment of all humankind. In this way, the exploration of the cosmos becomes a symbol of hope and possibility, a reminder that we can overcome our differences and achieve great things when we come together in pursuit of common goals. The journey to explore the gas giants and their moons is a long and arduous one, filled with challenges and uncertainties. Yet, it is a journey worth undertaking, for it holds the potential to transform our understanding of the universe and our place within it. As we cast our eyes towards the distant stars and the worlds that orbit them, we are reminded of the infinite possibilities that await us in the vast, uncharted territories of space. Each discovery, each new piece of information, brings us closer to a fuller understanding of the cosmos and the intricate tapestry of life. In this pursuit, we are guided by the light of curiosity and the desire to explore the unknown. The path may be fraught with challenges, but it is one that we must continue to walk, driven by the enduring quest to understand the universe and our place within it. As we look to the stars, we are reminded of the beauty and wonder of the cosmos, a reflection of the boundless potential of human imagination and the power of exploration. In this journey without end, we find solace and inspiration, knowing that with each step we take, we move closer to unraveling the mysteries of the universe and finding our place within it. In the vast expanse of our solar system, the gas giants stand as majestic sentinels, their swirling atmospheres and immense gravitational fields sparking a sense of wonder and curiosity. These behemoths, Jupiter, Saturn, Uranus, and Neptune, each hold secrets within their gaseous depths, mysteries that beckon us to explore further. The question of life within these immense worlds is one that captivates the human imagination. For these planets, with their turbulent clouds and hidden layers, present environments unlike any found on Earth. These gas giants, with their thick atmospheres composed predominantly of hydrogen and helium, seem at first glance to be inhospitable to life, as we know it. However, the possibility of life in unexpected forms or environments inspires scientists to look beyond the familiar, to consider life that thrives in conditions we might have once thought impossible. Jupiter, the largest of the gas giants, looms in the cosmic ocean with its iconic Great Red Spot, a storm larger than Earth that has raged for centuries. Beneath its swirling clouds, the planet's atmosphere transitions from gaseous to liquid metallic hydrogen, creating a landscape of crushing pressures and extreme temperatures. Yet, it is within the layers of clouds above that some scientists speculate microbial life could potentially exist, suspended in the hydrogen-rich atmosphere, feeding on the chemicals and energy sources available. This concept, though speculative, challenges our understanding of life's resilience and adaptability, urging us to consider the possibility that life, if it exists, may not always mirror the terrestrial forms we know. Saturn, with its stunning rings, offers another realm of possibilities. Its atmosphere, similar to Jupiter's, is comprised of vast, flowing bands of clouds, each with its own unique chemical composition and dynamic weather patterns. While the planet itself shares the inhospitable conditions of its larger neighbor, it is the moons orbiting Saturn that captivate scientists in the search for life. Titan, Saturn's largest moon, with its dense atmosphere and lakes of liquid methane, presents an environment starkly different from Earth, yet ripe for exploration. Titan's atmosphere is rich in organic molecules, the building blocks of life, and its surface, though frigid and alien, offers a tantalizing glimpse into what an alternative form of life might resemble. The European Space Agency's Huygens probe, which landed on Titan in 2005, provided invaluable data, revealing a world of ethereal landscapes and complex chemistry, a world that continues to intrigue and inspire. Beyond Saturn lies Uranus and Neptune, the ice giants, with their distant, frigid realms of swirling storms and deep blue hues. Uranus, with its unusual axial tilt, spins on its side, creating extreme seasonal variations as it orbits the Sun. Its atmosphere, composed of hydrogen, helium, and methane, is a place of chilly temperatures and muted colors. Yet beneath its clouds, it holds a mantle of icy materials, a reminder of the diversity of planetary environments. Neptune, the furthest of the gas giants, is a world of intense winds and dynamic weather patterns, its deep blue atmosphere hiding a core of rocky material surrounded by a thick mantle of water, ammonia, and methane ices. These distant giants, though less explored than their larger counterparts, offer a wealth of scientific opportunities, each possessing unique characteristics that challenge our understanding of planetary formation and dynamics. In contemplating the potential for life on gas giants, one must also consider the innovative technologies and methodologies that drive our exploration of these distant worlds. The instruments aboard spacecraft like Juno and Cassini have allowed us to peer into the swirling atmospheres of these giants, revealing insights into their composition, magnetospheres, and atmospheric dynamics. Spectroscopy, a tool that analyzes the light emitted or absorbed by materials, helps scientists identify the chemical makeup of these planets, providing clues about their potential to harbor life. The development of advanced telescopes, both on Earth and in space, continues to enhance our ability to study these distant giants, capturing images and data that expand our knowledge and fuel our imagination. As we ponder the possibility of life on gas giants, we must also reflect on the philosophical implications of discovering life beyond Earth. If life exists in the clouds of Jupiter or on the icy surface of Titan, it would redefine our understanding of life's adaptability and resilience, challenging the notion that life is a rarity in the cosmos. Such a discovery would have profound implications for our perspective on life, prompting us to reconsider our place in the universe and the uniqueness of Earth as a cradle of life. It would also raise questions about the potential for intelligent life elsewhere in the universe, encouraging us to continue our search for extraterrestrial civilizations and to remain open to the possibilities that lie beyond our current understanding. In this quest, international collaboration and cooperation are essential, as no single nation possesses the resources or expertise to explore the vastness of space alone. The shared endeavor of space exploration fosters a sense of unity and purpose, transcending borders and cultures as humanity works together to uncover the secrets of the cosmos. This collaborative spirit is exemplified in missions like the James Webb Space Telescope, a joint project of NASA, the European Space Agency, and the Canadian Space Agency, designed to probe the farthest reaches of the universe and search for signs of life on distant exoplanets. The pursuit of knowledge and understanding is a shared human endeavor, one that unites us in our common goal of exploring the wonders of the universe. As we continue to explore the gas giants and their moons, we are reminded of the importance of preserving our own planet, a beacon of life in the vastness of space. The study of other worlds provides valuable insights into the processes that shape planetary environments, helping us to better understand the delicate balance that sustains life on Earth. By examining the atmospheres, climates, and geological features of these distant worlds, we gain a deeper appreciation for the factors that contribute to habitability, guiding our efforts to protect and preserve our own planet for future generations. The journey of exploration and discovery is a never-ending one, driven by the innate curiosity and imagination that defines the human spirit. As we look to the gas giants and beyond, we are inspired by the possibilities that await, the potential to uncover new truths and expand our understanding of the universe. This pursuit is not without its challenges, but it is one that we must embrace, for it is in the search for knowledge and understanding that we find meaning and purpose. With each new discovery, we are reminded of the beauty and wonder of the cosmos, a reflection of the boundless potential of human imagination and the power of exploration. In this journey without end, we find solace and inspiration, knowing that with each step we take, we move closer to unraveling the mysteries of the universe and finding our place within it. This exploration of the cosmos invites us to reflect on the intricate tapestry of life and the universe, stretching our minds beyond the confines of our home planet. Among the many celestial bodies that pique our curiosity, the gas giants stand as titans of the solar system, their immense presence both daunting and mesmerizing. These colossal planets, with their swirling atmospheres and hidden depths, challenge our understanding of what constitutes a habitable environment. Unlike the solid surfaces of terrestrial planets, the gas giants are composed predominantly of hydrogen and helium, with layers that transition from gaseous atmospheres to liquid metallic interiors. The absence of a solid surface as we know it raises intriguing questions about the potential for life in such an alien environment. While the gas giants themselves may not offer the traditional conditions required for life as we understand it, their moons present a different story. The moons of Jupiter and Saturn in particular are of great interest to scientists searching for signs of life. These moons, with their icy crusts and subsurface oceans, offer tantalizing hints of the ingredients necessary for life. Europa, one of Jupiter's largest moons, has captured the attention of researchers with its vast ocean hidden beneath a thick layer of ice. This ocean, kept liquid by the tidal forces exerted by Jupiter's immense gravity, could harbor conditions conducive to life. The presence of water, coupled with the potential for geothermal activity on the ocean floor, makes Europa a prime candidate in the search for extraterrestrial life. Similarly, Enceladus, a moon of Saturn, has intrigued scientists with its geysers that spew water vapor and organic compounds into space. These geysers suggest that Enceladus, like Europa, may possess a subsurface ocean with the potential for life. The discovery of organic molecules in the plumes adds another layer of intrigue, hinting at the complex chemistry that may occur beneath the icy surface. These findings inspire missions that aim to probe deeper into the mysteries of these moons, seeking to uncover the secrets hidden beneath their frozen exteriors. As we expand our search for life beyond Earth, the concept of habitability itself becomes more nuanced. Life, as we know it, is a product of a delicate balance of conditions, including the presence of liquid water, an energy source, and the right chemical ingredients. However, the discovery of extremophiles on Earth, organisms that thrive in environments once thought inhospitable, suggests that life could exist in forms and places we have yet to imagine. These resilient organisms expand our understanding of life's potential, prompting scientists to reconsider the possibilities for life in the harsh environments of the gas giants and their moons. The study of extremophiles informs our exploration of the solar system, guiding our search for conditions that might support life. The ability of these organisms to endure extreme temperatures, high radiation levels, and intense pressures offers valuable insights into the adaptability of life. This adaptability is a testament to the resilience of living systems, a reminder that life finds a way to persist in the most unlikely of places. The exploration of the outer planets, with their complex systems and diverse environments, requires a collaborative effort on a global scale. The pursuit of knowledge transcends borders, bringing together scientists from around the world to share data, insights, and expertise. Collaborative missions, such as the Cassini-Huygens mission to Saturn and its moons, exemplify the power of international cooperation in advancing our understanding of the universe. These missions, driven by a shared vision of discovery, harness the collective ingenuity of humanity to unlock the secrets of the cosmos. As we contemplate the potential for life on the gas giants and their moons, we are reminded of the intricate web of connections that define our place in the universe. The search for extraterrestrial life is not merely a quest for knowledge, but a reflection of our innate curiosity and desire to understand our origins. This journey compels us to look outward, to seek answers to fundamental questions about life and the universe, while also prompting us to look inward, to reflect on the nature of life on our own planet. The exploration of the cosmos offers a unique perspective on the interconnectedness of all life, emphasizing the importance of preserving the delicate balance that sustains life on Earth. As we venture into the unknown, we carry with us the responsibility to protect our home planet, ensuring that future generations can continue to explore and discover the wonders of the universe. In this vast cosmic ocean, Earth remains our anchor, a reminder of the fragility and beauty of life. The pursuit of knowledge is a journey of wonder and discovery, a testament to the enduring spirit of exploration that defines humanity. With each step we take into the cosmos, we are reminded of the boundless potential of human imagination and the power of science to illuminate the mysteries of the universe. This journey, driven by curiosity and a desire to understand, is one that knows no bounds. It is a journey that inspires us to dream, to explore, and to seek answers to the questions that have captivated us for generations. As we continue to delve into the mysteries of the gas giants and their moons, we do so with a sense of awe and wonder, knowing that each discovery brings us closer to understanding the universe and our place within it. The exploration of space is a testament to the power of human ingenuity, a celebration of our capacity to dream and to reach beyond the stars. In this endless quest for knowledge, we find inspiration and solace as we strive to unravel the secrets of the cosmos and to find our place in the grand tapestry of the universe. As we gaze into the night sky, we are reminded of the infinite possibilities that await us, of the wonders that lie beyond the reach of our imagination. The exploration of the gas giants and their moons is but one chapter in this ongoing journey, a journey that invites us to dream, to explore, and to discover the beauty and wonder of the cosmos. With each step we take, we are reminded of the boundless potential of human imagination and the power of exploration to illuminate the mysteries of the universe. This journey, driven by curiosity and a desire to understand, is one that knows no bounds. It is a journey that inspires us to dream, to explore, and to seek answers to the questions that have captivated us for generations. In this vast cosmic ocean, we find inspiration and solace, knowing that with each step we take, we move closer to unraveling the mysteries of the universe and finding our place within it. As we continue to explore the gas giants and their moons, we do so with a sense of awe and wonder, knowing that each discovery brings us closer to understanding the universe and our place within it. The exploration of space is a testament to the power of human ingenuity, a celebration of our capacity to dream and to reach beyond the stars. In this endless quest for knowledge, we find inspiration and solace as we strive to unravel the secrets of the cosmos and to find our place in the grand tapestry of the universe. In our journey through the cosmos, The gas giants stand as majestic sentinels, captivating our imaginations with their swirling storms and vast, enigmatic atmospheres. These colossal planets, with their intricate dances of cloud bands and towering tempests, invite us to ponder the mysteries they hold within. As we gaze upon Jupiter and Saturn, Uranus and Neptune, we glimpse worlds that challenge our understanding of what it means to harbor life. While their turbulent clouds and immense pressures seem inhospitable, these giants inspire a deeper contemplation of the myriad possibilities that the universe may offer. Floating high above their tumultuous layers, we imagine the delicate ballet of particles, the interplay of chemistry and physics that might one day reveal unexpected forms of life, thriving amidst the elements. Beneath the thick veils of their gaseous exteriors, these planets possess cores of immense pressure and heat, where hydrogen transforms into exotic states. This hydrogen, compressed into a metallic form, conducts electricity and generates powerful magnetic fields that envelop the planets in protective shields of radiation. These magnetic fields, vast and dynamic, interact with the solar wind, creating auroras that dance across the polar regions in ethereal displays of light. Such phenomena, while mesmerizing, remind us of the complex and violent forces at play within these distant worlds, forces that shape the environments and influence the potential habitability of their surrounding moons. The moons themselves are a testament to the diversity and ingenuity of nature, each one a distinct world with its own character and story. Titan, Saturn's largest moon, is cloaked in a thick atmosphere rich with organic compounds. Here, rivers and lakes of liquid methane and ethane carve the landscape, creating an environment reminiscent of a primordial Earth. The Cassini-Huygens mission gifted us with images of Titan's alien vistas, sparking curiosity about the chemistry of life and the conditions under which it might arise. Meanwhile, on the icy moon of Europa, beneath a shell of ice that may be several kilometers thick, an ocean of liquid water is believed to exist. Heated by the gravitational forces of Jupiter, this hidden sea could harbor life forms adapted to its dark, high-pressure environment, much like the extremophiles found in Earth's deep oceans. As we extend our gaze to Neptune's moon Triton, we encounter geysers of nitrogen gas erupting from its frozen surface, a reminder of the dynamic processes that persist even in the coldest reaches of our solar system. The possibilities these moons present are boundless, each offering a unique laboratory for understanding the conditions necessary for life. In the vastness of space, where extremes of temperature and radiation challenge the tenacity of life, these moons may offer refuge, cradles where life could emerge and evolve. In considering the potential for life beyond Earth, we must also reflect on the fragile nature of our own planet. Earth, with its delicate balance of ecosystems and climates, is a rare and precious oasis in a universe of extremes. The study of other worlds, with their myriad challenges and potential, underscores the importance of preserving our own. It reminds us of the interconnectedness of all things, of how the fate of one world may be tied to the destiny of another. As we explore the cosmos, we must do so with a sense of stewardship, recognizing our responsibility to protect and cherish the life that has arisen on our own world. The scientific endeavors that propel us into space are fueled by collaboration and innovation. Each mission, each probe sent into the vastness of space, is a testament to human cooperation, a bridge that unites diverse nations and cultures in a common quest for knowledge. These collective efforts embody the spirit of exploration, the pursuit of understanding that transcends borders and unites us in a shared curiosity. As we continue to reach out into the universe, we carry with us the hopes and dreams of generations, the desire to comprehend the mysteries of existence and to find our place among the stars. In the quiet moments of reflection, we are reminded of the profound beauty and complexity of the universe that surrounds us. From the gas giants with their swirling storms to the icy moons that circle them, each discovery adds a new thread to the tapestry of knowledge, weaving together a story of wonder and exploration. Through the lens of science, we glimpse the intricate dance of creation, the forces that shape planets and stars, and the delicate conditions that allow life to flourish. As we draw this journey to a close, let us linger for a moment on the edge of possibility, where the known meets the unknown and where imagination takes flight. In the stillness of space, amidst the distant stars and the vast, uncharted territories that await, we find a sense of connection, a reminder of the boundless potential that lies within us all. For in exploring the universe, we also explore ourselves, unlocking the mysteries of our own nature and the profound capacity for curiosity and understanding that defines us. With each step we take into the cosmos, we affirm our place in the grand scheme of things, embracing the journey as much as the destination. It is a journey marked by patience and perseverance, by moments of insight and revelation, and by an enduring sense of wonder. As we continue to gaze out into the night sky, let us carry with us the quiet assurance that the universe is vast, mysterious, and full of promise, waiting to be discovered in its own time, inviting us to explore its secrets and to find our place within its infinite embrace.